Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have 1 divided by 25 minus 4x square. So what we have been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what our y is. So that's my y, integral of dx by 25 minus 4x square. So I know that my y is not in a very simple format whose antiderivatives I know from first principles. But can I solve this by resolving this particular expression 1 by 25 minus 4x square into partial fractions? The answer is yes, because 25 is nothing but 5 square and my 4x square is nothing but 2x the whole square. Allow me to do this on the same line. So that's my y with a little bit of rearrangement, and all that I'm going to do in step number 2 is do the substitution t equals 2x, right, and put back everything in terms of t. So when my t equals 2x, my dt becomes equal to 2 dx, which means my dx becomes equal to dt by 2, right? I go back to my y, and when I try and represent everything in terms of t, what do I get? My expression becomes my dx is dt by 2, and therefore I can pull out the 1 by 2, and then I have a dt divided by a phi square minus t square, right? Now I know that my denominator in this expression is of the format a square minus b square, which means I can rewrite this as a minus b into a plus b, and then use partial fractions to resolve this, right? So I'm going to retain my half, and I have my integral sign. Then I rewrite my dt by phi square minus t square as dt by phi minus t into phi plus t, right? Now, this is very simple when it comes to resolving this using partial fractions, and you don't have to elaborate this because this is probably the simplest of partial fractions that you have. Let me rewrite this particular expression post resolving it into partial fractions, right? So I have this as integral of, and I can write this as dt by phi minus t, right, plus dt by phi plus t, right? Take a look at this expression. What you actually get is, when you do the cross multiplication, and what you actually get is, in the numerator you will get a 10 because the t and t gets cancelled out, and in the denominator you will get back your phi square minus t square, right? So what happens is you have a 10 in the denominator, and to compensate for that you will have to add a 1 by 10 to this particular expression, which means I'm going to pull that 1 by 10 outside of the integral. You already have a 1 by 2 out there, and therefore it becomes a 1 by 20 times integral of dt by phi minus t plus dt by phi plus t. So my dt by phi plus t, I'll bring that first, and you will understand why in the next few seconds. And then my dt by phi minus t, I'm going to rewrite it as minus of dt by t minus 5, right? Does it change the expression? The answer is no. So this is what I have, and this is not very difficult because I can see that we have integral of a minus b, which is nothing but integral of a minus integral of b, which means I can rewrite my y as 1 by 20 times, and you have two integrals now, integral of dt by t plus 5 minus of integral of dt by t minus 5. Okay, so now this is of the form integral of dt by t, right? Both these expressions are of the form integral of dt by t. And I know that integral of dt by t is nothing but a ln of mod t. And if I replace the t with, t plus 5, the answer to that problem is ln of mod of t plus 5. And in the case of dt by t minus 5, it is ln of mod of t minus 5, right? So the answer to this particular problem, and remember we'll have to add our constants, is 1 by 20 times ln of mod of t plus 5 minus ln of mod of t minus 5, right? Now some of the textbooks which will give you a ready formula will express this as mod of 5 minus t, right? It doesn't really matter whether it's a mod of t minus 5 or mod of 5 minus t. It is all the same as long as it is inside the mod, right? And then I have my constant plus c, right? I have this of the format ln of a minus ln of b, which is nothing but ln of a by b, right? So I can go to the next line and rewrite my y as y equals 1 by 20 times ln of, then I have a mod of t plus 5 divided by t minus 5, right? And for the sake of textbooks, I'm going to write this as 5 plus t divided by 5 minus t, right? Mod of plus, you have your constant c. And remember, folks, we did a substitution originally t equals 2x, right? I cannot leave this in the form of t. So I'll have to put back everything in the form of x. So I replace my t with 2x, and therefore my answer to this problem is 1 by 20 times ln of mod of 5 plus 2x divided by 5 minus 2x plus c. So there we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.